Hello and welcome back to another episode of an Introduction to Calculus. Today we'll be covering the product rule and the quotient rules. So the product rule, I'll discuss that one first because it's the most fun and it's the most useful. So these rules kind of, they look similar to the chain rule, right? Because they're not about specific functions like exponential functions or quadratic functions or something like that. No, they are about like classes of functions. So the product rule, as you may already suspect, it's in the name, has to do with what happens when two functions are multiplied together. What happens when we need to say we have f of x times f of g, and we want to take the derivative of that. Well, I won't explain the entire derivation here because it's kind of boring and not very interesting. But you just take the first function and leave it at that, and then the second function take the derivative, or actually I'll put that apostrophe there, and then just add the first function, the derivative of that, and then multiply by the second function normal. So you just have the derivative, normal, or let me switch that around, normal, derivative, derivative, normal, and you add in the center. So this one's just, well, it's kind of just a rule to memorize. I can't really sweeten this one. No, alright, but I think it's most useful just to work through a couple examples with this, so you get the gist. Alright, so last video I explained things about exponential functions, so I think it will be fun to make use of that. So the first function that we'll be taking the derivative of is x times e to the x. Alright, so it will be useful to split these up, so I'll split these up in u of x and v of x. And we can then say that the f of x is just u of x times v of x, right? So, and that means we have to use the product rule. Well, u of x, what's that going to be? Well, I can kind of divide this up into two parts. That's going to be x times e to the x. Alright, so we'll set u to the x equal to x, and v of x will set that equal to e to the x. And now we can just take their derivatives just on their own. That's a lot easier. Alright, derivative of u to the x, that's going to be just 1. It's easy enough. And the derivative of v to the x, well, as we saw last video, pretty much the defining property of e to the x is that it is its own derivative. So that's going to be just e to the x. Alright, and now we can simply plug it into the formula. So the derivative of the entire function x e to the x is going to be, well, that's going to be the first function. That's u, that's just 1, times the derivative of the second function. That's just e to the x. And then we have to add the derivative of, oh, actually, I swapped those the wrong way around. No, we have to do the normal function first, right? To be honest, when you're adding, it doesn't really matter, but I like to stick by like my rule, right? Alright, so we have to do the first function normal, that's just x, and then the derivative of the second function, that's e to the x. And then we have to add the derivative of the first function, which is 1, and multiply that by the normal second function, that's e to the x. And so we can actually just factor e to the x, and we can see that it's e to the x times x plus 1. So that's how you use the product rule, right? So eventually you'll get used to how it works, and especially in the beginning, it's useful to kind of denote these separately, the u and the v, and work them out, right? Because it keeps things clear. Also, try to memorize, this rule helps a lot. So I'll just do one more example. So here we go, I'll go to the right, so I can still see the rule there. So just one more example, that's going to be h of x, it's going to be 3x squared plus 2 squared times, let's just do that times 3 to the x. Alright, so first of all, let's divide this up into two separate functions. Well, the first thing going to be this entire thing, 3x squared plus 2 all to the power of 3. And then the second part is just going to be that 3 to the x. So I'll denote these down separately. U is going to be 3x squared plus 2 all to the power 3, and then v is going to be 3 to the x. Alright, so now we'll take the derivatives of those. So the derivative of u to the u of x, that's going to be quite a long one actually, because we have to use the chain rule here, right? So if you don't know how to do this, rewatch the chain rule episode. Right, so first of all, we just need to take this 3 out front, right? That's our outer function, so we'll take 3 out front and just keep the inside the same. 3x squared plus 2, yes, plus 2, yes, squared, and then we have to do multiply by the derivative of the second function. Derivative of the inside function rather. The inside function, that's 3x squared plus 2, that's going to be 6x. And then just the derivative of v, that's easy enough, that's a natural log of 3 times 3 to 3x. Alright, and now we can combine all of that into our final derivative of h. Here we go. Oh, excuse me for that. Okay, don't know what happened there. Alright, no, the derivative of h. Well, let's just apply the rule. Right, we have to persevere now. No, first the normal u function. Well, it's easy enough. Just copy that to the power 3. Alright, and we have to multiply by the derivative of v here. So ln 3 times 3 to the x. Alright, it's going to be quite a long one, this one. Alright, we have to add the derivative of the second function. Actually, just there's 3 and that's 6. I'll put those together to 18x. Like that. That's a little bit nicer, I think. And then we have to multiply by the regular second function. So that's 3 to the x. And that is the final answer. That took quite a while. As you can see, the derivatives are getting more complicated, right? Because we started at what is the derivative of x squared, and now we're already doing things like this. So we're definitely getting somewhere. Alright, so that is the product rule. And now for the final thing, I will actually explain the chain rule, or excuse me, the quotient rule. So we have seen already that we can find the derivative when two functions are multiplied together, right? But now, what happens when two functions are kind of divided, right? What happens when we have divide, and when we divide two functions? So let's say we have t of x divided by n of x. What's the derivative going to be? Well, I'll tell you two approaches. So the first approach is to treat the denominator as kind of n of x. I can rewrite my function like this, right? And what happens then is this just becomes a product, and this I have to use the chain rule. But that becomes a little bit, that's just a little bit too complicated sometimes, and it's unnecessarily complicated. But this one will also work, right? If you can't remember the quotient rule, you can always use this. But the quotient rule, well, the quotient rule is actually derived from this. But the quotient rule, it goes as follows. So the derivative of this function here is going to be just the regular denominator squared, and then up top we'll get n of x times the derivative of t, subtract the derivative of n times regular t. So that's the quotient rule. That's a lot more, it's a little bit more messy than the product rule. I know, it's not that fun. No, but yeah, if you can't remember this, you can always use just this one. Alright, so we'll do a quick example for this one as well. Don't have to make it too complicated. Now we'll do e to the x divided by 2x plus 1. Right? Like that. Alright. First of all, what is our n? Our n is 2x plus 1. And our t is e to the x. Now then we'll take the derivatives. These ones are easy enough, I hope. E to the x, that just becomes e to the x. Very nice. and then this just becomes 2. And so now we can just plug it into the formula. First of all, we have to do n of x, that's 2x plus 1, by the derivative of t, that's just e to the x, and we subtract off the derivative of n, that's 2 times the regular t, that's like that. And then we have to do n squared, and I'll just leave it squared like this. I can still factor out e, which is kind of nice. So it'll become like this. And that is the final answer. So thank you for watching, and see you in the next part. Bye bye.